Hello, my name is Emeka. I'm representing Group 5 for Capstone Group, and our topic is the impact of right turn on red on pedestrian safety. First of all, we have to understand the problem. The project is aimed at improving urban safety for pedestrians in San Francisco. So we're trying to identify hot areas that are prone to right turn on red accidents. So the data set, we got data set from open data. And the data set has 76,511 rows and 91 columns. The method we're using in this project is data collection, data cleaning, data exploration, feature selection and engineering, and data modeling. So we created after all our analysis, we created a dashboard, as you can see, that which shows details of the accident counts, the distribution of victims, the total accident by year. This is another dashboard that is about the right turn on red, where it shows the accidents by race and party types involved in the accident. Um, Key insights from those dashboards, we can see that individuals aged 20 to 39 are frequently affected by right turn or red accidents. We also noticed top accident prone routes like Mission Street and Market Street. Also noticed that the clear weather is the most common condition that occurs during accidents. And we also noticed that the weekend shows a slight decline, indicating reduced traffic volumes, which contribute to fewer accidents. Also, the approach we're taking in the machine learning part of predicting the prone areas we're using convolution neural network, which is CNN, and our CNN approach is by we're using the images are being processed using Opus CV2 library, and we use label encoding for encoding the data, and also we also use CNN for predicting and finding.
So I'll be continuing from where Emeka stopped. So did a feature engineering. We added a feature named ARM, which took into consideration whether the person involved was injured or if somebody got killed. Also, we built a CNN model using functional API. These are the layers of the model, and using the model, we were able to evaluate the model. We got an accuracy of 1, which showed that the model was overfitting. As a result, we had to augment our data, and in augmenting our data, we use the smooth method. Yeah, so after using smooth to augment our data to reduce overfitting, as you can see from here, our test accuracy actually reduced from 1.0 to 0.67. And then after that, we carried out predictions using our model. So from the predictions we got, you can see that intersection ID 300,700 has the highest prediction of accident incidents, recording a total of 31 um, accidents predicted to happen at this intersection. So some of the challenges we encountered during this project were actually getting the images that we're going to incorporate into the data. Um, we also had issues with the code because we had to learn how to like map the data we had downloaded to the structured CSV file that we had. And then there was also the constraint of the hardware our computers kept crashing because we didn't have like sufficient space to run the kind of heavy lifting that this project required. As a result, we actually took about 15% of our data to run this model. So for future research, we advise that left turn accidents be actually looked into, because from our observation, from our exploratory analysis, we were able to see that more accidents actually happen when people are making a left turn. Would also advise that red light cameras be deployed to enforce this right turn on red rule. Um, and they will also consider restricting right turn on red at high accident intersections during peak hours. Here are the references we had while carrying out this project. Thank you.